So now we do some linear inequalities based on modulus function. So here, based on modulus, we already discussed modulus function in function chapter. So if you just recall definition of modulus function, fx equals to modulus x, where modulus x is given by x if inner number is positive. If it is 0, then it is 0, so you can write greater than or equal to 0. And here minus x if inner number is negative. So when you drop the modulus, you ask for inner number. If it is positive or 0, then it is replaced by itself. And if it is negative, then you need to put minus in front of this. Okay. So here, in general, you can write modulus x equals to plus or minus x. That's a general way of writing definition of modulus. If greater than or equal to 0, then it is just x. When it is negative, it is minus x. This is about equality. Now we have here results about inequality. So here the first result, that is modulus of x is less than a, where a is any positive real number, remember, where a is any positive real number, a belongs to R plus. Modulus of x is less than a if and only if, so I'll write double implication, x is between minus a and plus a. X is between minus a and plus a. This is the result. It can be proved. We are not getting into that. But this is always true, remember. Modulus of x is less than a if and only if we have this between minus a and a, where a is any positive real number. For example, here, suppose modulus of x is less than 1 if and only if x is between which two numbers? Minus 1 to plus 1. Every number from minus 1 to plus 1, remember. You just recall this if you have this here. For example, modulus of x equals to 1, then we write x equals to plus or minus 1. We write like this. But this is about equality. So we have just two numbers. X can be minus or plus 1. In both the cases, answer will be 1. But here we have inequality, remember, less than. Here less than. Then x is between minus 1 and 1. What is the meaning of this? Here you see on the real line, this is 0, this is minus 1, this is 1. Every number from minus 1 to 1, that is this one, excluding these two numbers, this number. And this means what? Open interval minus 1 to 1, if you remember. So this means x belongs to this, open interval minus 1 to 1. The meaning of this is this. We may have like these also, remember. Here, second result, if I write modulus of x less than or equal to a. So now a is included. That means x is between minus a and a, including these two n numbers, remember. So here, if I just show on a line, on a real line, if I show it, here from minus a, suppose this is 0, this is minus a, this is plus a. From minus a to plus a, all these numbers. So this is called closed interval minus a to a. That is, here closed interval minus a to a. X belongs to closed interval minus a to a. We have this here. Okay. What's the difference between this one and this one? The only one number. Here you have open interval minus a to a. Here you have closed interval minus a to a. Fine. This is one thing. Here a is always positive, remember. A is always positive, like 2 here. Okay. Now, the next result, that is about greater sign. The third one, that is modulus of x is greater than a. Now see, what's the meaning of this? Let us see here. Modulus of x is greater than a. That means, that is, plus or minus x is greater than a. Fine. That means x is greater than a or minus x is greater than a. Either x is greater than a or minus x is greater than a. I'll keep this one as it is. X is greater than a. Here I'll just multiply with minus sign. You know, if I multiply with minus sign, I'm multiplying with minus sign. Inequality get reversed. So this become x. Here this become less than minus a. So we have these two things, remember. So what this says, whenever x is modulus x is more than a, then either x is less than minus a or more than a. So if and only if here either x is less than minus a or here x is greater than a. We have these two things. You can just keep this much also in your mind. The meaning is this precisely. That is, if you want, you can write here, that is plus or minus x is greater than a. And then immediately you have this, remember. If I show it just here on a line, you will realize further. Suppose this is 0, here your minus a, here your plus a. Or here x is more than a. So this portion, x is less than minus a, so this portion, this much. Both the numbers are excluded. How do I write this? Minus a to minus infinity. So you can write minus infinity to minus a. How do I write? A to plus infinity. You can write union here. This or this. Or means union. Right? This is the precise meaning of this one. Remember. For example, if I write here, modulus of x is greater than 1. Now here, what's the meaning of this? Plus or minus x is greater than 1. It means what? Either x is greater than 1 or minus x is greater than 1. This one we keep as it is. X is greater than 1 or just multiplying with minus sign. X is less than minus 1. So either this or this, remember. We have this one. So if I just look at it here line, this is 0, this is minus 1 and this is 1. So x is more than 1. So from 1 to infinity. 1 to infinity. Union x less than minus 1. So this portion. So minus infinity to minus 1. This is the solution of above inequality. Every number from minus infinity to minus 1 or from 1 to infinity satisfy this inequality. This is about modulus. On the other way around, if I write this, suppose if I would have written this, one more example here. Suppose I wrote like this, second one, modulus of x is less than 1. Now you know, this means x is between which two numbers? Minus 1 and plus 1. So here x is between minus 1 and plus 1. So in that case, what is the solution? From minus 1 to plus 1, this interval, this much portion on the real line. Right? From minus 1 to plus 1. This is the values of variable x for which modulus is always less than 1. You pick up any number from minus 1 to 1, put here its modulus is less than 1. What this is, you pick up any number from this portion, from 1 to infinity or minus infinity to 1. That is either from this or from this. You put just in this inequality. You will notice that its modulus would be more than 1. Fine. So we have two important results which you need to keep in your mind. One is modulus of x is more than 1 and the other one is modulus of x is less than a here. They're more than a. Okay. So based on this two results, I'll just discuss some examples here. Let's see on a real line. Question is here. Examples, let's see this. What is the question? Solve the inequalities. This is a question here. Solve the inequality and represent on a line. And represent on a line. This is a question. Okay. So here the first question is, let's write this. Modulus of 4 minus x is less than 2. Let's write this. Solve the inequality means you get the condition on x as we did earlier. Here you have just modulus, remember. So what I'll do, I'll just imagine this bracket like x. You imagine this entire bracket like x. And then use this result. Which result? Modulus of x is less than a if and only if x is between which two numbers? Minus a and plus a. From minus a to plus a. So if I imagine this is like x, it implies 4 minus x, that's like x, is between which two numbers? Minus 2 to plus 2. I did nothing. I will just use this result straightforward, remember. I repeat, this is like a. So minus a to plus a. This inner expression is like x. So x is between minus 2 to plus 2. Now you are interested to find x. So first I need to eliminate 4. Now as we did earlier question, so I need to subtract 4 throughout. Minus 2 minus 4, 4 will get cancelled. Minus x minus 4 plus 2. Subtracting 4. So this is minus 6 less than minus x less than here minus 2. Now usually we need x only, so I'll just multiply with minus sign. If you multiply with minus sign, you know inequality get reversed. So this become plus greater than x greater than 2. That is same as if I just do write from 2 to 6. This is a solution from 2 to 6. So solution you can write like this also. You know that this is open interval 2 to 6. Every number from 2 to 6 satisfy given inequality, right? Suppose here I have 2, here I have 6. So from 2 to 6. Every number from 2 to 6 satisfy this inequality. From 2 to 6. This is the representation on a line. You pick up any number from this place here, you will see that its modulus will be less than 2. That's called the solution. You know it. The only important step is this one, remember. Then such things we did it number of times. So this is not big task for you, remember. Okay. Let's see one more question here. Second question. Suppose I have modulus of 2 plus x plus 1 less than, let's write 2. This is inequality. What's the question? Question is this. Solve the inequality and represent the solution in the plane. So what I need to do first, I have less than sign. So I need to express in this form, remember. So only modulus should be there on the left hand side. Everything should be on the RHS. So I'll take 1 on the other side. So 2 plus x is less than, I'll take 1 on the other side. So 2 minus 1 gives us 1. Now what we do? We use this result. Which result? Modulus of x less than a if and only if x is between which two numbers? Minus a and a. X is between which two numbers? Minus a and a. Remember, we use this result. Now imagine this is like x. So 2 plus x is between -1 and 1. You imagine this is like x. So this number is between minus a to a, that is from -1 to 1. Now you don't want this 2. So as we did earlier, what we do? We subtract 2 throughout. -1, -2, x less than 1 minus 2, you know. So this is -3 less than x less than -1. So this is a solution. So what is the solution here? Solution is from -3 to -1. This is the solution. Okay. Now let's see one more question about that less than sign. So modulus of x minus 1 less than 5 and the modulus of x less than or equal to 2. You have two inequalities. So we find the solution for this, and we take the common. And means intersection, you know. Now how we'll do this? You imagine this is like x. So x minus 1 is between which two numbers? -5 and 5. You know this. We have used twice now. Which result I have used? This one. Modulus of x is less than a if and only if x is between which two numbers? -a and +a. I have used this. Okay. So from -5 to 5. We are interested for x, remember. So what we do? We add 1 throughout. So this is -4 less than x less than 6. So for first portion, solution is from where to where? -4 to 6. Okay. Go to this. What's the meaning of this? X is from where to where? -2 to 2, remember. Here 2 is included, -2 is also included. X is from where to where? -2 to 2 here. Okay. So one is this, the other one is this. Now we'll just try to see the common. If I draw the line, you will understand very easily. Suppose this is 0, here we have -4, somewhere here we have 6. So one is from -4 to 6. Now what about the other portion? The other portion is from where to where? -2 to 2 here, remember, close interval. So you must have now noticed what's a common in these two. This comma means and, remember, and means common. So what's the final solution? Solution is close interval -2 to 2. What's the meaning of this? Every number from -2 to 2 satisfies both the inequalities, these and this, remember. That's the meaning of and, you know. Fine? Okay. Now here, let's see one more question about modulus. So for example, I want this. The question is, solve this. Modulus of x is less than or equal to 0. What's the meaning of modulus of x is less than or equal to 0? It means drop the modulus. X is between -a to +a. That is -0 to 0. So x has to be 0. So 0 is the only solution which satisfies this condition, remember. One more, like this. Modulus of x minus 2 less than 3. So this x minus 2 is between which two numbers? -3 to +3. Then adding 2 throughout the inequality because I need x only. So -3 + 2 -1 less than x, here 5. So solution is from where to where? -1 to 5, open interval. This is the solution. Okay. Now let's see some questions based on greater sign. So here one question, let me consider this here. Let's see this question. Modulus of x plus 7/3 is greater than 2/3. Now here remember your greater sign. So we have two possibilities, you know. You can write like this, therefore plus or minus x plus 7 by 3, I've just dropped the modulus, is greater than 2 by 3. So either x plus 7 by 3 is greater than 2 by 3, or I'll take minus on the other side. So x plus 7 by 3, if I take minus on the other side, you have less than minus 2 by 3. You know it. You can write this step directly also from this if you want, but I've shown that intermediate step. Now you get x from this. I'll take 7 by 3 on the other side. So 2 minus 7 by 3, which is minus 5 by 3. So x is greater than minus 5 by 3. Or here I'll take on the other side. So here x is less than minus 7 minus 2, that is minus 9 by 3, which is minus 3. Fine. So you can just show it on the line. This is 0. Here, you know, this is minus 1 point something, and this is minus 3 here. This is minus 5 by 3. Here x is more than minus 5 by 3, so this portion, and x is less than minus 3, so this portion. Right. So this is the solution. So solution you can write like this here, minus 5 by 3 to infinity, this portion, or means union, you know, minus infinity to minus 3. Required solution, remember. Let's see next question. Suppose modulus of x minus 2 is greater than 1. We are solving modulus, remember. Now what's the meaning of this? You have greater sign. So plus or minus x minus 2 is greater than 1. So either x minus 2 is greater than 1, or minus of x minus 2 is greater than 1. I need x, so I'll take 2 on the other side. So either x is greater than 3, or here I'll just take minus sign on the other side. So x minus 2 is less than minus 1. I'll take 2 on the other side. So x is less than 1. So if I just present these on a line, this is 1, this is 3. Here we are saying that x is more than 3. So either this portion. So 3 to infinity, solution. X is less than 1, so this portion. So here we have minus infinity to 1, union. This is the solution. Solution. Every number from this portion, that is from this or this, will satisfy this inequality. You can pick up any number. See, if I take any number from 1 to 0, it will not satisfy this inequality. You can verify. Suppose I have taken 1.5. 1.5 minus 2, that is minus 0.5. Its modulus 0.5, which is not bigger than 1. So no number from this will satisfy this inequality. But every number from this or this portion would satisfy the inequality. You know it. Okay. Now here one more question. Let's see this. Modulus of x minus 1 is greater than or equal to 2. So this is like x. Plus or minus x minus 1 is greater than or equal to 2. So therefore x minus 1 is greater than or equal to 2. Or directly I'll take minus on the other side. X minus y is less than or equal to minus 2. You know it now. So I did it directly. Greater than or equal to 2 or less than or equal to minus 2. So x is greater than or equal to 3, or here x is less than or equal to, you take 1 on the other side, so minus 1. So solution here, x is greater than or equal to 3, so 3 to infinity. Union from minus infinity to minus 1. This is the solution. Let's see one more question. Solve this. This is the question. Solve this x minus 3 with modulus equals to x minus 3. This is the question. This is not about inequality. This is about equality. Now here you need to just recall the definition of modulus. When modulus of x become x, you recall modulus of x equals to x if this number is greater than or equal to 0, remember. Then and then this is possible. So it means, it implies that inner number has to be greater than or equal to 0, otherwise this is not possible, remember. This is a straightforward conclusion by definition of modulus, remember. What's the definition of modulus? Modulus x equals to x if inner number x is greater than or equals to 0. So here the inner number equals to, you have that same number. That means that inner number has to be greater than or equal to 0. That means x has to be greater than or equal to 3. So greater than or equal to 3 means what? 3 to infinity, remember. So here solution is closed interval 3 to infinity. 3 to infinity. You pick up any number from this portion, you will see that it satisfies the given equation. You take 4 minus 1, 4 minus 3, 1, here also 1. But if you take any number from this portion, this 2 will not be equal. Therefore, this is the solution. Now, here some questions which are based on not modulus, like this. See this question, solve this inequality. Again, the question is same. 1 upon x minus 4 less than 0. Now here variable is in the denominator. Earlier we have not come across such questions, remember. Okay. Now just you need to think, this is a rational expression. So when the rational expression is negative, either this is positive and this is negative. It's a rational expression. So either this is positive and this is negative, then entire expression is negative. Or this is negative and this is positive, then the entire expression is negative. But here numerator is always positive because it's 1. वो तो फिक्स्ड है, तो a पॉजिटिव है, दैट मीन्स a नेगेटिव ही होना चाहिए. Then and then the entire expression is negative. This question doesn't arise here, remember. So यहाँ से आप क्या बोल सकते हैं? This has to be negative. X minus 4 has to be 0. Then and then entire expression is negative, remember. Take 4 on the other side. So x is less than 4. So what's the solution? X का value 4 से कम होना चाहिए. That is from where to where? Minus infinity to 4. This is the solution. Starting from here, suppose 4, then this side, minus infinity to 4. You pick up any number from minus infinity to 4, you will see that this expression will be negative. Okay. Likewise, if I see this question here, question number 8, let me see that. What it says, solve this equation. Question is same everywhere. Solve x square upon x square plus 1 is less than 0. Now, just need to think for a while here. This is negative. As I explained, you have two possibilities, but can you recall? This is always positive, greater than or equal to 0. You know, x squared is always greater than or equal to 0. Square of a number never be negative. If it is a complex number, it can be, remember. आप जानते हैं iota is a complex number. आप square करो, answer -1 आएगा. But here we are talking about real numbers, remember. So x square is positive. X square plus 1 is always positive. तो greater than 1 होगा in fact. A भी positive है. Numerator is positive. Denominator is always positive. Positive upon positive हुआ. So can this be possible? No. So what's the solution here? Null set. There is no x. There is no x for which x square upon x square plus 1 is less than 0, remember. It's always greater than 0. Now let me do one question. There we have variable upon variable. So question is solve this. X plus 3 upon x plus 5 is greater than 1, where x is any real number, remember. We have not discussed such questions in our exercises. There you have variable in the denominator also, remember. So in such questions what we do, we bring 0 on RHS. I'll take 1 on the other side, left hand side. This is very common method. Minus 1 greater than 0. Always you bring 0 here. Therefore, if you just simplify, minus x minus 5 upon x plus 5 is greater than 0. So this is minus 2 upon x plus 5 is greater than 0. Now again ratio, remember. When this is positive, if both are negative or both are positive, remember. There are indirectly two possibilities. If this is positive and this is positive, the entire expression is positive. Or if this is negative, then the entire expression is positive. But here numerator is minus 2, which is always negative, like this. So therefore this has to be negative, remember. So therefore x plus 5 has to be less than 0. You cannot take this over here, remember. In ratio you cannot do here, in inequality you cannot take denominator on the other side. Right? Otherwise this is not even possible. आप इसको इस साइड ले लेंगे तो क्या हो जाएगा, -2 greater than x plus 5 into 0. So -2 greater than 0. ये तो possible ही नहीं. Negative number cannot be more than 0. So this cannot be done. You need to do like this in ratio questions, remember. Positive, negative and so on. This is negative. This has to be negative. Then and then the ratio is positive. So you have this and therefore x has to be less than -5. So what's the solution here? Solution is from where to where? Minus infinity to minus 5. This is the solution. Every number from minus infinity to minus 5 satisfy this inequality. Okay.